All right, 4.6 talks about the graphs of sine and cosine functions. It says the graphs of sine and cosine functions are periodic. This means that the function values will repeat as x increases. The sine value of a function is equal to the y value at the corresponding point or angle on the unit circle. Also, the cosine value is equal to the x value at the same point or angle. All right, so first we're going to talk about the graphs of the graph of y equals sine of x. All right, so now remember, we have our unit circle. And on our unit circle, we have these quadrantal angles here. We have 0, which has an ordered pair of 1, 0. We have this one up here, which is pi over 2, which has an ordered pair of 0, 1. Then over here, we have the angle of pi, which is an ordered pair of negative 1, 0. And then down at the bottom, we have the angle of 3 pi over 2, which has the ordered pair of 0, negative 1. And if we go a complete circle, then we also have the angle of 2 pi, which shares the ordered pair of 1, 0. All right, so when I go to make my parent table for y equals sine of x, I'm going to use those angles, and I'm going to use those ordered pairs. Okay, so my angles there are just 0, the pi over 2, pi, 3 pi over 2, and 2 pi. Now it does tell me here in example 1, it says since the graph will complete one full cycle in the interval from 0 to 2 pi, the period of y equals sine of x is 2 pi. So it's going to take 2 pi for that graph to start repeating itself. And so that's why I'm going to set up my table from 0 to 2 pi. Now remember, y is equal to sine of x. And sine is y over r. But we're on the unit circle, remember r is 1, so the sine is just the y value of the ordered pair. So when I look at 0 radians over here, I see its y value is 0. At pi over 2, its y value is 1. At pi, its y value is 0. 3 pi over 2, its y value is negative 1. And at 2 pi, again, its y value is 0. And guys, it's just periodic, okay? It's going to keep repeating itself over and over. Trig functions have patterns. If you look at these, they're all, I'm going to put it in degrees, they're all 90 degrees apart, or they're each a pi over 2 apart, okay? X's are going to be in even increments. Your y's are going to be formed by a pattern. They'll be in even increments as well. All right, so when we graph this, it's going to look like this. Nice rounded curves. Do your best. I know it's new. Okay? And it will keep going. So I could have followed my pattern and went back to the left. Now if I'm going to go to the left, this point right here corresponds with this point. Okay? And like I said, it's a pattern. To get to the next point on the left there, we went left 2 lines, down 2 lines. Left 2 lines, down 2 lines. Then to get to the next one, I went left 2 lines, up 2 lines. So left 2 lines, up 2 lines. And then we could just keep repeating that pattern, okay? All right, so looking at that, keep yours up so you can see it. Some characteristics. Now I'm just going to sketch mine. Well, I shouldn't have done that, but that's okay. All right, so if I just sketch mine real quick here. All right. It does keep going to the left and the right, so the domain is negative infinity to infinity. Now my graph only goes down to the negative 1, and it only goes up to positive 1, so therefore its range is negative 1 to 1 inclusive. Now I'm going to skip the x-intercept for just a minute. Let's go to the y-intercept. It crosses the axis at the origin, so the y-intercept is 0, 0. Now, for the x-intercept, it crosses more than once. Because this graph keeps going, it crosses infinite number of times. So I can see there's one here, there's one here, there's one here, and I know since this graph is going to continue, there's going to be another one here, and another one here, and it's going to keep going. So what you do is you're just going to pick one of them. And I usually pick my smallest one that I can see there that's still not a negative number, which is 0. Okay? But I notice, how far is it from 0 to the next one? Well, the next one on your graph, you'll notice is at pi. And so from 0 to pi is pi. So it's going to be 0 plus pi, and then we're going to put k. Now I'm going to simplify that. 0 plus anything is just the anything. So this is just going to give us pi times k. And then we're going to put k, this little funny looking e, and a z. And so what that means is that K is an element. An element is a number of, okay? So it's an element of and the Z stands for the integers. Remember when you talked about different categories of numbers and stuff? And like you said, all numbers were real numbers. And then from there, you had some that they were rational or they were irrational. Okay, so, and it's just an abbreviation thing. You may or may not have learned it. Most of y'all learned like this one, which means all real numbers, right? Well, Z is just representing the set of numbers as the integers, which is our positive and negative counting numbers. So -2, -1, 0, 1, 2, 3. There's no decimal, no fraction to them. And so this here is just notation, okay? Anytime we put that K, we have to identify that it's not going to be a fraction or a decimal, okay? That it's an integer. All right, so there is my x-intercepts. Now the maximums. Notice you have a maximum right here. And if my graph kept going, we'd have another maximum here and another maximum like over here. And so a maximum to a maximum or a minimum to a minimum is going to be one complete cycle. And so we said that it's 2 pi apart. So we're going to find our first maximum there, which is at pi over 2. And they're going to keep happening every 2 pi. So plus 2 pi k. And because we use k, just use your symbolism here, okay? K is an element of the integers. Then your minimum. Okay, we have a minimum here, we have a minimum here. If we went to the left like we did on the one I drew above, we'd have a minimum over here. You just need to pick one of those minimums. And so I'm going to go ahead and just pick the one that's at 3 pi over 2. And like maximums, they're going to happen every 2 pi because a minimum to a minimum is going to be a full period. So we're going to add that plus 2 pi k. And because we use k, we need to use our notation. Now, is our graph continuous? Does it keep going to the left and right? No holes, no gaps, no jumps? Yes. Is it bounded above? Is there a line that it won't go above? Yeah, it doesn't go above 1. What about bounded below? Doesn't go below 1. Or excuse me, doesn't go below -1. It asks about the symmetry. Is it even or odd? Well, remember, cosine and its reciprocal are the only two even functions. Therefore, sine has to be odd, which means it is symmetric to the origin. And then to ask for the key points, we're going to see above, because those key points are what we put in our table. And so that just keeps us from having to rewrite it again. All right, the graph of y equals cosine of x. It's the same thing. We're going to use those same ordered pairs, okay? 0 and 2 pi, which both have the ordered pair 1, 0. Here was that pi over 2 that has the ordered pair of 0, 1. Pi, remember, has the ordered pair of -1, 0. And 3 pi over 2 has the ordered pair of 0, -1. Now, same idea. Period. Remember, period and cosine are going to look very similar, okay? Cosine and sine are just shifts, the graphs of them. I'm sorry, I don't know if I said the graph or the period of them. The period is the same because the graphs are the same graph, just one of them is shifted. So, when we're looking for y equals cosine of x, it has a period of 2 pi as well. And so we're going to use those quadrantal angles to help us graph this. All right, remember that cosine is your x value. And so my x value here for 0 is 1. My x value at pi over 2 is 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, it's back at the +1. And so that's going to be our parent table for cosine. So when we graph this, okay, it looks something like this. And again, it's repetitive. It keeps going and it repeats. So, okay, my thing just paused on me there for a second, so I don't know what we caught, but I had said D does what it's supposed to. So a positive d will go up, and a negative d will go down. Sorry guys, give me 1 second. I'm having to plug in the iPad. It is going dead, and then I dropped it there. All right. So let's continue. So that is our transformation. So same thing that we talked about last semester when we did transformations. It is nothing new. Also, remember that when you go to do your tables, the vertical stuff affects the y. So that's the a and the d. So with y, it does what it's supposed to. So you'd multiply it by whatever the a is, and then you'll add or subtract whatever d is. But remember, everything inside with x does the opposite. Even PEMDAS is backward. So we're going to take x, we're going to subtract c, and then we'll divide it by that b to help you with your tables. All right. So let's go back into our notes now, and we can talk about amplitude and the period of sine and cosine. So amplitude is when we change the height or the amplitude of the graphs of sine and cosine functions by transforming the equation of the function. This will change the range of that parent function. So y equals 2 sine of x. So that 2 is a vertical stretch by 2. It's my a value. And so when we make our new table, we're going to take our y's and we're going to multiply them by 2. So go back and look at your sine table, okay? My x's are going to stay the same, so I'm just going to rewrite them. And my y's are all going to be multiplied by 2. So 0 times 2, 1 times 2, 0 times 2, negative 1 times 2, and 0 times 2. And then you can just graph these functions. Graph these ordered pairs, I'm sorry. Now, if you compare it back to the first table, you're really not going to be able to tell much of a difference because they changed the scale on this one. The original table that we graphed on the first page, every 2 lines was a whole number going up and down. Here, every line is a whole number. So it's going to be hard to kind of compare it to it. But you'll notice, instead of going down to negative 1 and up to positive 1, this one's going to go down to negative 2 and up to positive 2. All right. Y equals negative cosine of 2x for B. 1 second. All right, sorry about that. So the graph of y equals negative 2 cosine of x. Remember the negative, we expect to see this reflect across the x-axis. And the 2 is going to be that vertical stretch by 2, okay? So we're going to use our cosine parent table, and we know that that's just with our a, so it's only going to affect our y, so we're just going to multiply our y's by negative 2. So again, I'm just going to rewrite my x values because they're not being affected. I'm going to take all of my y values for my cosine. We changed trig functions here, okay? For my cosine graph, I'm multiplying by negative 2. So we get 1 times negative 2, 0 times negative 2, negative 1 times negative 2, 0 times negative 2, and 1 times negative 2. All right, and then we can just graph those points. And if we compare it to the first table that we did on the second page of our notes, we can see that, that's not a great graph, sorry. And so we can tell that it did reflect because cosine originally started at on the y-axis at the top. Now it's at the bottom. But again, it's hard to tell that the stretch because of the different scale on our x's, on our y-axis. All right. So, but in both examples, the amplitude is 2. In general, we can say that y equals a sine of bx or y equals a cosine of bx, and the amplitude is defined to be the absolute value of a. So we know that the amplitude is equal to the absolute value of a. Now, I'm also going to go ahead and share with you, because we'll need it later, that if they give me an equation, okay? I find the amplitude by taking the absolute value of a. If they don't give me an equation, but they give me a graph, you're actually going to take your maximum minus your minimum, and you're going to divide it by 2. Amplitude is the height of our graph from the center of the graph, okay? So from the center of the curve. So if we look at that last one, we can see here that my center is right here, and it goes 2 above, and it goes 2 below. Therefore, that amplitude was 2. All right, then the period. We've already established that the period of the parent sine or cosine graph is 2 pi. But let's explore how the general form of the equations can change the period of the graph as well. So if we have a b value, our period is going to change. So we got y equals sine of 2x. Well, this 2 here, it's inside with x. It's going to be horizontal. It's being multiplied, so it's going to be a stretch or compression. Since it's being multiplied by 2, that means it's compression by the reciprocal of that number. So what we're going to do then is, because it's inside with x, it's going to affect my x's. And it says 2 times x, but remember, it always does the opposite, so we're going to take our x's divided by 2. But remember, dividing by a number is the same as multiplying by its reciprocal. Now, we're going to use our sine parent table, and notice there's nothing on this graph that's going to affect, or in this equation that's going to affect my y's. So I'm going to go ahead and write them. Sine starts at 0 and goes up, and then it has to come back down, and then it goes back up. And so I'm going to take my x's. My first x was 0, and I divide it by 2, which is still 0. Then I'm going to take my pi over 2, my next x. Now, dividing by 2, that's a fraction within a fraction. So instead, I'm going to use the fact that it's the same as multiplying by 1/2. And so that gives me pi over 4. Then I'm going to take my my third x, which is pi, and it doesn't matter if I do divided by 2 or times the 1/2. Either way, I come out with pi over 2, because remember, that's over 1, and we multiply straight across. Now remember, we said that the x's were evenly spaced, okay? So if you see a pattern, you could continue your pattern. But I'm going to keep going. So we got 3 pi over 2 times 1/2, 3 pi over 4. And then 2 pi, I'm going to do times the 1/2. 2's cancel, so we just get pi, or we get 2 pi over 2, which is still just pi. And so look for that pattern. 0, 1/4, 1/2, which is 2/4, 3/4, and pi, which is 4/4. And so therefore we can graph this then. Now, I don't have pi